Hi, everybody, and welcome to another class in your Web3 course. This class is going to be about big data. And let's get started by defining what is big data. So big data is defined as the quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording data. So that's first the definition of data. And what about big data? So big data is a collection of data that is huge in volume, yet growing exponentially with time. It is a data with so large size and complexity that none of traditional data management tools can store it or process it efficiently. Big data is also data, but with a huge size. So when we say that, we have to look at what are the characteristics regarding big data. And there's 3 V's. So it's the volume. So for example, every single cell phone user in the world currently produces 40 hexabytes of data per month. And that will be multiplied by the amount of users there are, which there are approximately 5 billion users. Now, look, what about the velocity, the variety, the veracity, and the value of the data? So the volume being a substantial amount, the velocity is, for example, on a daily basis, there's a large amount of data being produced. How is the data? Is it standard? Is it semi-formatted? Is it disjointed data? And then we have to look at things like, is this data accurate? So for example, medical records, who validates them and puts them into the system, and how can we know that the data is true? And furthermore, what about the value of the data? What information are we getting out of the data that is being produced? So for example, if someone is, recording data about patients that recover, that is a very valuable data because it allows for research. How many days was the patient in? Things like that, especially in the field of medicine, as I will use for this specific example. But there's many examples, which include things like, for example, in the aeroplane sector, data produced by airplanes, their flight time, the amount of errors occurring, the amount of turbulences between what area. This data allows for predictive analytics, which then allow companies to make choices that allow them to better run their companies. So, but as I said, these factors are very important because when companies are making decisions, when they're looking at the data that is being produced, they want to make sure it's authentic. They want to make sure they can format it. They want to make sure that they're getting it fast enough, and they can process the volume of the data that's being produced. And so other examples of big data include things like Facebook, the stock market, and jet engine information. There are 2.1 million snaps produced today. There's 3.8 million Google searches that are completed per day. 1 million activities I'm assuming now, 1 million activities on Facebook, and 4.5 million videos watched per day. So those are other examples of what big data is. Moving forward, how is that in Web3? What is the difference between the current state of data being used and produced in the world versus what will it look like in a Web3 world? Well, in a Web3 world, more people will have ownership of that data. So if I'm a patient and I have my information, I get to choose if I want to share it or not share it and monetize on it with healthcare providers. Also, if we have artificial intelligence, they can optimize data storage, data production, and data analytics. So going into things like predictive analytics. Furthermore, we have to look at a concept called oracles. Oracles provide a way for decentralized Web3 ecosystems to access existing data sources, legacy systems, and advanced computations. Decentralized Oracle networks enable the creation of hybrid smart contracts where on-chain code and off-chain infrastructure are combined to support advanced decentralized applications, dApps, that react to real-world events and then interoperate with traditional systems. So what does this mean? What do I mean by this? Well, in a big data example, let's have a look. There's data produced all the time. And so what if there's a game that you're watching and it's a sport match, and then you and someone else make a bet? How is all the information you have learned in this class, what is the ability for you to combine it? Well, think about it like this. We did a lesson on smart contracts, and we did a lesson on different cryptocurrencies and what is a blockchain. So if blockchain is immutable, then how can it interact with the real world and get the proper information? Well, and for that information to be decentralized. Because, for example, if I want to send Ethereum to my friend and I want it to be a dollar amount versus the actual amount of Ethereum, then how will a blockchain know that is correct? So what happens in this case is you need an oracle that is decentralized versus centralized, because then it will take away from the whole idea of Web3. For example, Amazon stores a lot of the information in the world. There's only so many big companies that provide data storage. And the problem with that is if something happens and this goes down, the infrastructure is less secure than what a blockchain is. So how can we combine this real world information, big data, weather data, stock market data, jet engine data, Facebook data, and provide that information so decisions can be made on chain? Well, you have those smart contracts. So let's look at it. You have raw crypto exchange data, let's say the price of Ethereum at that time, from multiple sources. Then you have places that are price aggregators. Then you have Chainlink node operators, and then they are then aggregated on the Oracle network and sent to the blockchains that they're interacting with. So think about it as a way of keeping the idea of being decentralized there versus having only one source of data. And if you would like a visual of how this works, here is what it would look like. And the thing is that the reason this is super important is because we are moving into a decentralized world. If you're only getting your source, one source, and you have two people trying to look at the same source, there is something that can go wrong. It's a security problem. So in order to solve that problem, you make it decentralized. And that's the thing about smart contracts. They can only be executed properly and the information taken properly if the data source is correct. Garbage in, garbage out. If you have the proper information coming into your system, then you will be able to produce the correct information at the output. And I cannot exaggerate the importance of smart contracts in these specific systems, because really the the information needs to be accurate and validated. So so let's go through these concepts again. You have large amounts of data. And then how do I process that data? How do I get it? How do I retrieve it? How do I move it? And how does it interact with the blockchain? Well, what happens is and Chainlink is only one example, you have decentralized systems that solve this issue so that you are less prone to risks of security, data accuracy, and really centralization, because we're trying to move away in this Web3 world from a centralized world where your information is only coming from one place. And there's an issue with that because of security and because of that accuracy. Really, when you're able to get that information from multiple places and validate that information, you're more likely to have a higher level of security. That's why nodes are run on the blockchain. When you take the information and it's validated by multiple sources, you're more likely to have an accurate set of information. And when it's decentralized, that's another factor that really makes it very highly secure. So thank you so much for joining me in this class, and I look forward to speaking with you soon.